So now see, generally we have a doubt. So in the previous case, when we discussed about the Z parameters or Y parameters, for Z parameters we are using V1 equal to Z1 into I1 plus Z12 into I2. Similarly, for Y parameters we are using I1 equal to Y11 into V1 plus Y12 into V2. So in that case, we are using the plus symbol, but here we are seeing the minus here. See, we are using the minus here. That is the difference that is one of the difference between the ABCD parameters and the remaining parameters. So why you are choosing the negative sign here is, I told in the previous in the whiteboard, I told initially that the transmission system, for the transmission circuit, at one end of the transmission circuit which is connected to the generation station, power is injected. At another end of the transmission system where substation is connected, power is drawn. At one end power is injected, from other end power is drawn. So for if you assume on circuit, at one end current is entering, at another end current is leaving generally. But see, when we discussed in the initial class on the 2 days before, 1 day before, 2 days before, we are assuming that the notation or direction of the currents at each port are entering into the circuit. For all 2-port network studies, we are assuming that current I1 and current I2 are injecting into the or entering towards the circuit. But actually, in case of the transmission, this was what happened. The current is entering toward the circuit at the input side, whereas at the output side, current is drawn or leaving from that circuit. So because of that reason, we are taking the negative sign here. Generally, we are assuming the I2 for our circuit purpose. We are assuming the I2 such that the current is entering at the second port. But actually, what happened is current is drawn from the second port for the transmission system. So because of that reason, we are taking negative sign here. Minus and minus. So that's the only difference for the ABCD parameters and Z remaining parameters. Here we are able to see the minus sign, because in actual case for the transmission system in the second port the current is drawn, but in our study we are assuming that current is injected into the circuit. So because of this opposite directions, we are using the negative sign here. So from here. Remaining all are similar. Remaining all are similar. What we discuss for the Z parameters and the Y parameters. So now we will discuss. Yeah. Now we will discuss. Right. Now, see. Now by using the equation 13 and 14, first I want to calculate transmission parameter A. Suppose if I want to calculate transmission line parameter A, suppose if I want to calculate transmission line parameter A, then what you have to do? It is the same, similar to the what we discussed in the Z parameters and Y parameters. Same procedure for here also we can. 1 minute. Okay. Right. So suppose if we want to calculate the parameter A, then what you have to do? We have to make I2 equal to 0 in this equation. So make I2 equal to 0. So make I2 equal to 0 means what it represent? Open circuit, second port. Open circuit the second port. That means we have to open the second port. So if you open the second port, then I2 equal to 0. When I2 equal to 0 in the first equation, then we have the V1 equal to A into V2. Then what is the value of A? The value of A equal to V1 divided by V2. That's it. Okay. So suppose if you want to calculate the parameter A, transmission parameter A in a given 2-port network, first of all you have to make the second port open. So once you make the second port open, then try to calculate the V2, voltage across the second port. If you open the second port, that means only current is 0. Some voltage will be existing across the voltage terminal, across the output terminal, second port terminal. So measure that voltage V2 and take the ratio between V1 and V2. It will provide the value A. Similarly, with this I2 equal to 0 or open circuit in the second port, we are able to calculate the C also. Right? Because when the I2 equal to 0 in the second equation, when the I2 equal to 0 in the second equation becomes I1 equal to C into V2 and C equal to, so C
I1 by V2.
I1 by V2. So that means if you want to calculate A and C parameters, then you have to open the second port and measure the voltage across the second port. That is V2. So after, and also you have to measure the current I1 also. So after measuring the current I1 and V2, then calculate the A that's equal to V1 by V2 and calculate the C that's equal to I1 by V2. Next thing, now if you want to calculate B and D parameters, suppose if you want to calculate B and D parameters, you want to calculate the B and D parameters,
Equals to 0.
we have to make V2 equal to 0. So we have to make V2 equal to 0 means we have to voltage 0 means that will be the short circuit. So make the short circuit second port. So short circuit the second port. So short circuit the second port. Now, if you make the VT equal to 0 by short circuiting the second port, then the first equation will be V1 equal to minus B into I2 and B equal to minus V1 divided by I2. Because V2 equal to 0, we are short circuit the second port. When the V2 equal to 0, we have the V1 equal to minus B into I2 and B equal to minus V1 by I2.
అనేది పెట్టుడు మొత్తం అది అవ్వడానికి అటు
బాబు మొత్తం దిగుమనేసి నీళ్ళు స్టార్ట్ చేస్తూ పోవాలి.
And suppose if you have any other conversation, try to mute your screen. That's also possible in the Zoom. So try to mute your screen. So, zero. Sorry. It's a D. D equal to.
ధైర్యం బండి దెబ్బ సరే అనుకో అర్థం
I'm requesting.
Guys, you are disturbing, sir. So please, all of you, mute your audio. You're disturbing. You're drawing the attention of sir. Everyone, mute your video.
So
please continue, sir.
Some other conversation, you can mute your video. Not an issue now. Yeah. So now D equal to. So when you make V2 equal to 0, that means second port is short circuited. V2 equal to 0, then D equal to. From the second equation, V2 equal to 0, and the V2 equal to 0, I1 equal to minus D into I2, and D equal to minus I1 divided by I2. That means, now we will summarize once for all these things. If we want to calculate the transmission line parameters or ABCD parameters of any two-port network, first open the second port and make I2 equal to 0. Then you are able to calculate A parameter and C parameter by taking the ratio between V1 and V2 and I1 and V2 respectively. Similarly, if you want to calculate the B and D parameters, of a given two-port network, then you have to short the second port. That nothing but make V2 equal to 0, voltage at the second port equal to 0. So after short circuiting the second port or making the voltage equal to 0 in the second port, then B equal to minus V1 by I2 and D equal to minus I1 by I2. So this information is sufficient to solve any problem or to solve any two-port network and to calculate the ABCD parameters or transmission parameters of any two-port network. And this information is also useful for you in the power station 2 subject for calculating the ABCD parameters of the different type of the transmission lines. So I hope these things you understood, because if you understood the Z and Y parameter, this is also easy, and next H parameter is also easy. Right. So this is the procedure for calculating the A, B, C, D parameters or transmission parameters of any two-port network. Now, I move to the next slide. So what we discussed till now, that is available in all the 15 to 18 equations. So A equal to V1 by V2 at IT equal to 0. That means open the second port. And B equal to or minus B equal to V1 by I2 or B equal to minus V1 by I2 at V2 equal to 0. That means second port is short circuit. And C equal to I1 by V2 at I2 equal to 0 means second port is open. And minus D equal to I1 by I2 or D equal to minus I1 by I2 at V2 equal to 0 means at the second port is short circuited. That means by making the second port short circuited, we are able to calculate the B and D parameters. And if you open the second port, that means by making the I2 equal to 0, we are able to calculate the parameters A and C. So that is the summary. This is a complete summary for the two-port network. This is very simple and this is a complete summary of the two-port network parameters. Next thing is, so we will same circuit. We will discuss how we calculate the ABCD parameters or transmission parameters of the given small two-port network. Now we will solve this problem. However, this is a simple concept, but what is required is we need a more practice. So don't think that the circuits will be as simple as what you are seeing in the screen. So there may be a complex two-port networks also will be given in the examinations and also in the competitive examinations. So try to practice more by using any textbook. I don't want to suggest you have to follow this textbook. You can take any textbook. So take one circuit and practice yourself. So by making the more practice, you can solve very complex problems easily. Now we will discuss how we solve the circuit for calculating the transmission line parameters. For calculating the transmission line parameters. Right. Now, so we will discuss now. We will solve this problem. If you are able to understand this one, you can solve any problem by yourself. Now this is the two-port network having the two ports having the voltage V1 and I1 at the first port and V2 and I2 at the second port. For the complete study, we are using that currents are entering into towards the port, towards the network. So both I1 and I2 are moving towards the network. Because of that reason only, we are choosing the minus B and minus C instead of plus B and plus D for the transmission line parameters. Now, first I want to calculate A and C. I want to calculate A and C. So how we calculate A and C? So if you want to calculate the A and C, I think we have to make I2 equal to 0, right? We have to make I2 equal to 0. Right? In the previous in the previous slide we discussed it. V1 equal to A into V2 minus B into I2 and I1 equal to C into V2 minus D into I2. So if you want to calculate the A and C parameters, you have to make the I2 0. I2 0 means, so second port must be open. Second port must be open. Second port must be open. Now, so when the second port is open, so no current is flowing I2. There is I2 equal to 0. No current is flowing. Okay. Now, so when I2 equal to 0, so you have then, let us assume this is the input source is here, V1, some voltage is connected. So current is I1 is flowing and this current is I1 flowing like this. At this node, the current is divided through 20 ohm resistance and divided through 5 ohm resistance. And what is the value of the current flowing through the 5 ohm resistance is flowing like this, As the current in this branch equal to 0 because it's open. So the current flowing through the 5 ohm resistance, total current is flowing through the 15 ohm only and coming back to the first port like this. Hope you are understand. So this current I1 is splitted through 20 ohm and remaining current is flowing. Sorry, remaining current is flowing through. Remaining current is flowing through 5 ohm and 15 ohm and fed back to the input port. So there's a So one current is flowing to the 20 ohm resistance and remaining current is flowing to the 5 and 15 ohm resistance and fed back to the input. So from this diagram, we can conclude that 5 and 15 ohm resistance are connected in series because there is no current division. Total current is flowing to the 5 ohm resistance and 15 ohm resistance remains same. Same current is flowing like this. So 5 ohm resistance, 15 ohm resistance are in series, and that equivalent resistance is parallel with the 20 ohm. So now we need to calculate the equivalent resistance. So R equivalent, that's equal to 5 and 15 are series. So 5 plus 15, because these two are in series, and this is in parallel with the 20 ohm resistance. In parallel with the 20 ohm resistance. So now the equivalent resistance equal to so so 5 and 15, that's equal to 20 parallel with 20. That is 10, right? 10. That's the 20 into 20 divided by 20 plus 20.
20 plus 20.
So that's equal to 10. So equivalent resistance equal to 10. Equivalent resistance equal to 10 ohms. Now the equivalent resistance equal to 10 ohms. Now what is the value of I1? So I1 equal to V1 divided by 10. I1 equal to V1 divided by 10. Right? So this is the I1 equal to V1 divided by 10. Right? So this is the total current which is injected into the first port of the given two-port network. See, I said that if you want to calculate the parameter A, so V1 equal to A into V2 minus B into I2. So A equal to V1 by V2. That means I want to calculate the V2 now. I want to calculate the V2 now. So V2. So V2, I want to calculate the voltage across these two terminals. So voltage across these two terminals is nothing but the voltage across the 15 ohm resistance. So voltage across the 15 ohm resistance is nothing but the current flowing to the 15 ohm resistance into 15. So can I write V2 equal to, can I write V2 equal to voltage across the 15 ohm resistance, that nothing but current flowing through the 15 ohm resistance. Current flowing through the 15 ohm resistance into value of the resistance, that's equal to 15. Now what I want is, I want to calculate what is the value of the current flowing through the 15 ohm resistance. So what is the value of the current flowing through the 15 ohm resistance? So current flowing through the 15 ohm resistance, nothing but current flowing through this branch, this blue color. That means there are the two parallel paths. One is the 20 ohm, another is the 15 plus 5, 20 ohm. Now I want to calculate the current flowing through the 15 plus 5. So that's nothing but the current flowing through the 15 ohm. So what is the current flowing to the 5 ohm resistance? Same current is flowing to the 15 ohm resistance. So I want to calculate the current flowing in this branch. I want to calculate the current flowing through this branch. So that's nothing but the I15. So I15 equal to total input current I1 into opposite branch, that's equal to 20 divided by sum of these two, that's equal to 20 plus 5 plus 15. So that value equal to so that's equal to I1 into this is the 20, numerator is 20, denominator is 15 plus 5, 20 plus 20, 40. So if I made any mistake, please let me know. So 20 divided by 20 plus 25 plus 15, 40. So that's equal to 20 by 40, 1 by 2, that's equal to 0.5 I1. So I15 equal to 0.5 I1. I15 nothing but current flowing to the 15 ohm resistance is nothing but the 0.5 into I1, 0.5 into I1. Now I want actually my aim is I want to calculate the V2 now. So V2 equal to, from this equation, V2 from here, V2 equal to I15. So I15 equal to 0.5 into I1. So 0.5 into I1 yeah 0.5 into I1, right, into, so that's equal to I15 into 15, right, into 15.
7.5.
Yes, 7, that's equal to 7.5 into I1, and that's equal to 7.5 into, we can write I1 as a V1 by 10. See, we can write I1 equal to, this is I1, right? This is the I1. So we can write I1 equal to V1 by 10. So we can write here V1 divided by 10. V1 divided by 10. So finally what I get is V2 equal to 7.5 by 10 means it is a 0.75 V1, right? So from the previous discussion, how we calculate the A value? So A equal to V1 by V2, right? Right, V1 by V2, that's equal to A. So A equal to V1 divided by V2, that's equal to V1 divided by V2, that's equal to 1 divided by 0.75.
1.33.
1.33. Okay, 1.33.
33.
33, okay, 1.33. Right. So now what are the units for the A parameter? Yesterday we discussed that for Z parameters we are using the ohms, and for the Y parameters we are using the moles. Now for the A, what is the value of units for A?
No units.
No units. There is no
Constant.
for the A. We just is the voltage gain. There is no units. V1 by V2, both numerator and denominator are the same units. So there is no units. It's no units here. So we calculated the A value. Now, so what is the another parameter we are able to calculate by making the second port is open? That is the C, right? So how we calculate the C? So how we calculate the C? Anyone able to remember? C, how we calculate? C
I1 by
I1 by V2, right?
I1 by V2.
Right, I1 by V2. Good. I1 by V2. Now, so how we get that thing? Anyone can tell how we get I1 by V2? Simple. See, in this equation, come here, this equation. From that equation, I1 equal to V1 divided by 10. Is it okay, Nama? No. And come to this equation, V2 equal to 0.75 into V1, right? So from that equation, V2 equal to 0.75 into V1. Ante kadamma? So from this equation,
By 10.
from this equation, we can get V1 equal to 1 divided by 0.75 into V2. Right? From this equation, we can write V1 equal to 1 divided by 0.75 into V2. Now replace this V1 expression here. Now replace this V1 expression here. Now what is the value of I1? So I1 equal to V1 equal to idikadamma. So V1 equal to the 1 divided by 0.75. V2 I1 equal to V1 divided by 10 and V1 equal to 1 by 0.75 into V2 into 1 by 10. Agree everything? See, this is the equation I am concerned. I1 equal to V1 by 10. I1 equal to, and from this equation, V1 equal to 1 by 0.75 into V2 into 1 by 10. Right? So, from this equation, C equal to I1 by V2. Now, anyone can tell C equal to, what the value of C? That's equal to I1 divided by V2. That's equal to, that's equal to 1 divided by 0.75.
0.133.
1 divided by 0.75 into 0.1. Ante kadamma? C value. So anyone can tell what the value here?
0.13.
0.133. Okay, 133. And now what are the units for the C?
3.
Okay, 133 something. So now what are the units for the
units.
Units.
No units.
Amma?
More.
Right, most.
No units. More.
It's the numerator is a current and denominator is a voltage. Amps by volts. It's like a admittance. I by V, it's like a admittance.
Admittance.
For admittance, the units are the moles. Right? So in this way, we can calculate the A and C parameters. Hope you understand how we calculate the A and C parameters. Now, suppose actually I got some notification that our session will be closed at 5:30. If the Zoom people will provide some extra time, we will continue. If somewhere it is disconnected, we will continue the tomorrow. Now, and now A and C already calculated. Now my aim is I want to calculate the B and D parameters. I want to calculate the B and D parameters. Okay. So now coming to the B and D parameters. Yeah. Now I am going to discuss how we calculate the B and D parameters. Suppose if we want to calculate the B and D parameters, so what you have to do, Gutundama? B and D
Open
parameters.
circuit, second port.
Yes, we have to make
Short circuit.
V2 equal to 0 and short circuit second port. We have to short circuit the second port. We have to short circuit the second port, right? No. 1 minute. So short circuit the second port. So short circuit the second port means, so this V2 0 or short circuit the second port. That's nothing but so we have to short circuit the second port like this. The second port is short circuited now. If the second port is short circuited, anyone can tell what is the significance of this 15 ohm resistance?
0.
0. There is no significance of the 15 ohm resistance. Just forget about the 15 ohm resistance, because if there is a short circuit across any resistance, there is no current flowing through the resistance, then you can simply neglect, there is no significance of that resistance. So just forget about the 15 ohm resistance. Now your circuit contains only 20 ohm resistance and 5 ohm resistance, and 20 ohm resistance and 5 ohm resistance are in parallel or series?
Parallel.
Yes. So these are in the parallel, because we are just forget about this one. Forget about this one. So these are 20 ohm and this is the 5 ohm. So these two are in parallel. So equivalent resistance equal to, and 20 into 5 divided by 20 plus 5, that's equal to, and 20 into 5. 20 into 5 divided by 20 plus 5.
4 ohms.
Entama? That's equal to 4. So that's equal to 4. So equivalent R equivalent equal to 4. Once you get the R equivalent 4, then what is the value of I1? So I1 equal to V1 divided by 4. Okay, na? I1 equal to V1 divided by 4. Next, what you have to calculate? We have to calculate I2, right? Yeah, V2 equal to 0. So we need to calculate I2. So this is the I2. This is the I2. Now I want to calculate the current flowing through the 5 ohm resistance first. So calculate the current flowing through the 5 ohm resistance, that's equal to current flowing through the 5 ohm resistance, that's equal to I1 into opposite resistance, that's equal to 20 divided by sum of these two, that's equal to 20 plus 5. So that's equal to some I5, current flowing through 5 ohm resistance, that's equal to
0.8 I1.
from 0.8 I1. 0.8 I1. That's equal to I5. Now, if you observe this circuit, so I want to write I2 equal to minus I5, right? Because I5 current flowing through the 5 ohm resistance, actual current flowing through 5 ohm resistance in this direction. But we are assuming the I2 in the opposite direction. So I2 equal to minus I5, and that's equal to minus 0.8 I1. Minus 0.8 I1. So we get the I2 equal to minus 0.8 I1, right? Now, so tell me, what is the formula for D? Try to recollect how we calculate the D.